Bismillahirrahmanirrahim. We continue our lesson, HM260 with subtopic 3.3, Instrumentation for Film AAS. We look at the instrumentation for AAS. Okay, so we have two types of AAS. We have single beam AAS and we have double beam. So this is single beam. From the name, single means that the beam from the lamp or from the radiation source is just one. Okay, this is the one that will pass through the sample, and this is the one that will pass through the reference or the background. Okay, so we have the radiation source. This is power, this is radiation source, this is flame where our sample exists here, and this is actually monochromator or wavelength selector. Yeah, we have entrance slit here. This is concave or dispersion medium. This is also dispersion medium grating, and this is exit slit. Then we have shutter to go to the detector. This is amplifier and the readout system. For double beam AAS instrument, from the names, we know that it has a double beam. Yeah? But basically the component is almost the same. We have radiation source, we have a flame or sample, we have wavelength selector or monochromator, data detector, and data processor. But the difference between double and single is here. We have a chopper to split beam from the radiation source into two. One will go to the sample and one will go to the reference or the background. Okay, so it can differentiate the absorption that come from the sample and that come from other than sample. Okay, by using the chopper or the a rotating mirror. Okay. In the double beam instrument, the radiation from radiation source or from hollow cathode lamp is split into two beams. One will pass through the flame and another one will go around the flame, means that will go to the background. Okay. A half-silvered mirror return both beams to a single path, then pass through a monochromator or wavelength selector, then we'll go to the detector. The monochromator is placed between sample and the detector. Okay, this is explanation for double beam instrument. For subtopic 3.3.1, we will look at the specific component of the AAS instrument. Okay, the first one we look at the sources, the radiation source. For AAS, we use line source. Okay, radiation source in AAS is a line source which provide narrow emission band because atomic spectra is a line spectra. The common radiation source used in AAS is HCl and EDL. Okay, the first one is HCl. HCl is actually hollow cathode lamp. The second one, EDL, is the electrodeless discharge lamp. Okay, you just remember the names. Okay, HCl for hollow cathode lamp, electrodeless discharge lamp for EDL. This is the only two radiation source commonly used in the AAS. This is for your extra knowledge. You don't have to memorize all this. Okay, this is hollow cathode lamp. It get his name from the design, okay, because the cathode is hollow, ada hole, so that's why it's got his name, hollow cathode lamp. Okay, so it is normal like other lamp, but it is quite specific because it use quartz or Pyrex window. Okay, The material used to fabricate this lamp cannot absorb radiation. Okay, so we have glass shield. This is glass shield. This is anode, and this is cathode, which has a hole. And inside this tube, this glass or quartz tubes, it has neon or argon gas at 1.5 torr. Yeah, so this is important for the operation of the hollow cathode lamp. But you don't have to know how hollow cathode lamp operates. The anode is normally, okay, kita baca, light from this lamp exactly light required for the analysis. Even no monochromator is used. If you want to analyze copper, you must use copper lamp. Okay, if you want to analyze mercury, you have to use mercury lamp. What does it mean by mercury lamp, copper lamp, or that a specific element lamp? It is actually element that contained in that lamp, because hollow cathode lamp must contain the element to be determined. If not mistaken, the anode is actually made up of from the element that we want to analyze. So that's why hollow cathode lamp has many types of elements. We have copper hollow cathode lamp, mercury hollow cathode lamp. We have many lamps for HCl. Okay, in this slide, it explains how does HCl works. But for me, this is not very important for your syllabus, but it's good for your general knowledge. You can read this on your own. Okay, the same for this one. This is also mechanism operation of hollow cathode lamp. Again, okay, in this slide, we will look at the electrodeless discharge lamp or EDL. This is a diagram showing EDL. It has a quartz window. Again, the material must not absorb radiation source. If not, our analysis will be more error. Okay, it will introduce error in our analysis. Okay, so this is the EDL fabrication design. Okay, dia ada lamp dekat sini, dia ada RF coil kat sini, radio frequency coil, and this is ceramic holder. This lamp is constructed of a metal or salts of interest, which is sealed in a quartz tube that filled with a noble gas, either neon or argon at low pressure. The same with the HCl just now. The noble gas is ionized and accelerated by strong radio frequency, RF coil, or microwave field, and excite to the metal or salts of interest. And then EDL can provide radiant intensity, usually 1 or 2 order of magnitude greater than HCl. Okay, the intensity of EDL is higher compared to HCl. Okay. But actually, this is not very important. You just need to know what is electrodeless discharge lamp. Bismillahirrahmanirrahim. We continue our lesson, CHM260 with subtopic 3.3, Instrumentation for Flame AAS. For subtopic 3.3.2, we will look at the source modulation. Source modulation is one of the important processes in atomic absorption spectroscopy to differentiate a radiation from a radiation source and also radiation from the flame of the sample. Okay, because in the flame absorption spectroscopy, we use flame. This process being done using this device, which is called chopper. Okay, if you look at this one, this is the radiation beam. This chopper have 4 segments. 2 of it is the transparent part, which will allow the radiation to pass through. 2 of it is the opaque part or the mirror part. that will block the radiation from the radiation source to pass through the and reach the detector. Okay, so this is the chopper. This is chopper, and this is the symbol for chopper. If we found this in the instrumentation drawing. Okay. Okay, this slide will explain how light chopper works to modulate or to eliminate the effect of radiation from the film. Okay, so this is light chopper. We have a transparent part and the opaque part. So the function of light chopper is to eliminate the effect of radiation from the film, as we already discussed in the previous slide. Light is chopped with a rotating half mirror so that detector could receive two alternating signal. Uh, at one time, it detect the signal from the radiation source, and another time it will detect a radiation from flame plus radiation source. Okay. At the time when the opaque uh, blocking the radiation beam, only light emitted by flame is read by the detector, since the light from the radiation source is cut off. Okay, the detector can only detect radiation from the flame. Then when the transparent part being directed to the radiation beam, light from both flame emission and the radiation source from the lamp will be reach the detector. Okay, so transmission from the source light is measured since the source light is allowed to pass. Okay, absorbance of the sample is determined by measuring the difference in radiant power between flame emission signal and signal from the radiation source. So actually, these two slides uh, might be confused. It's better to just refer the one yang ada graph tadi. Yeah. Okay. Hopefully, this slide will explain better, yeah, how the source modulation being performed and how we get the analytical signal. So, chopper is used to discriminate or to differentiate between the radiation from the radiation source, which is hollow cathode lamp, and also the radiation from the excited atom in the flame, or radiation from the flame, by alternately passing through the flame and being blocked off. Okay, by alternately allow the radiation from the lamp to pass through, and also block the radiation from the lamp. Okay, okay, this is lamp. When chopper at the position of the transparent part, it will allow the radiation from the lamp. So we get the signal from the lamp and from the flame. Radiation from the flame we cannot stop, or we cannot eliminate. The detector will always get a signal of a radiation from the flame. Okay. Uh, when the chopper at the location that block the radiation from the lamp, the detector will only read a signal from the flame. So we can get this kind of graph. This is radiation from the flame. This is radiation from the flame plus lamp. And the difference between flame and lamp plus flame is an analytical signal. So that is why source modulation is important in the flame atomic spectroscopy. This